Hi everybody. My name is Matrana. I hope you're all well. So let's get started. So we have a question here, right? So there's a question right here. So before we get started, right? Some of you. So the question. Let's get started with the question straight away. They say a siren of a train. So there's a train which is moving at a constant speed. Also, the speed of the train is constant. Okay, the speed of train is constant along the horizontal track, but that train is gonna emit the sound. See? But before we get started with this question, see, let me explain something very crucial, with this such a topic. Just 1 minute. Look, okay, this is Doppler effect. So phase, in Doppler effects, we're gonna be dealing with the two things. We're gonna be dealing with a listener and a source. What do you mean about the listener source? For example, let's say there's ambulance. The ambulance. Let's say this ambulance car, and this you who's standing here. Oh, okay. This ambulance car and this, let's say, is you. Let's assume. So the ambulance is coming. So the ambulance is moving, let's assume, but you standing. So you the listener, okay? You're the listener and the ambulance is the source. Why? Because here we're going to be dealing with the frequency and velocity and frequency. You see what I'm saying? That's what you're going to be dealing with. So now, you the listener, because you're the one who's going to detect that sound of an ambulance, and the ambulance is going to be coming. So the ambulance is the source, okay? So, and then you're going to be hearing something, but what you're going to be hearing, there is a medium of propagation. What is a medium? Medium here is the air or airspace. So it should be medium of propagation where you're going to be hearing that frequency. What is frequency meaning? Look, frequency is like a pitch, like the way how you're going to be hearing so the way how you hear that pitch, that means it's a frequency. That pitch you hear, that's a frequency. And the unit of frequency, which you represent using F, that's a frequency. The unit is Hertz. Hertz. For example, I hear 10 Hertz. You just write 10 Hz. So the frequency that when the ambulance was coming was 4 Hertz. You understand what I'm saying? But now let me ask something. For example, if the ambulance is coming to you here, are you going to hear high frequency or low frequency? I'm going to hear more frequency because this ambulance is coming toward me. Let's say I'm going to hear, let's say 10 Hertz, which is two assumptions. But when it's leaving, when the ambulance is somewhere here, I'm going to hear, let's say 5 Hertz. You know why? I'm going to hear 5 Hertz because Hertz is the unit of frequency. Because now the ambulance is moving away from me. Means the frequency is going to be means the pitch is going to be. But when it's coming to you, because coming to you, towards you. That's why I hear more frequency. But when it's leaving me, it's going to start to fade away. You're going to be here little. So we have two cases. We have a source. What's going to produce the source? For example, for this case here, they say a siren train. Mean the train. So this train, siren, that's a source. But you, if you're standing, let's say, and then you the listener. But there's a different case. There's a case where the ambulance is coming and you're standing. And there's a case whereby the ambulance is coming and you're also coming. Or another case, let's say the ambulance is standing there, maybe ambulance or train, but it's still horning like or a car, and then you coming toward the source. So you the listener as a person. Let me just raise this. So there's a different case. Either the source is stationary. Let's say the ambulance is at the stationary. Maybe someone is sick, so the ambulance is coming toward. No, so the ambulance is standing here, maybe to fetch a patient, or the car, and the robot, and then you coming. Maybe you walking toward the traffic light. So meaning the source is a stationary, but you as a listener, you walking toward the source. So we're going to do different type of question based on either the listener is moving toward the source or the source moving toward the listener. So now let's go to this question here. So there's a little formula we're going to use. I'll show you now. For now, just know what is the frequency, meaning, like I say, frequency like a pitch. Okay? And the medium of propagation, it depends. But for most cases, if I hear the ambulance, how did I hear? Because the medium of propagation, the medium between me and the ambulance, or me and the train which is coming or is moving away, is airspace. So that's a medium of propagation. Okay? Now, let's go to the question now. So they say siren train. So that train like that's a train moving at a constant speed. Oh, so the train moving at a constant speed along the straight horizontal track. Oh, so it moves at the railway, let's say, in a track. But this train is gonna emit the sound. Oh, so the train is gonna produce the sound. So you're gonna hear them, okay, at the constant velocity. So this constant frequency, oh, so the frequency of a train is not gonna change. You see what I'm saying? It means the frequency of a train is gonna be the same when it moves. It's not gonna be same. It's not gonna change. So frequency of a source is not gonna change. For now, they have not given us any data. They say detector, so we have a detector here. It could be detector or someone is listening, so they put some devices. Place next to the track means, let's say this is a railway train. So they decide to put a detector here. Let's call it D, detector. So this detector is going to record all the frequency. So since this detector is going to record the frequency, meaning the frequency of a listener, we can have it. Because the detector is going to be recording the frequency of what? Of that train when it's coming, of that source when it's coming. So who's going to hear here? The detector. So frequency of a listener we might have. But let's continue and read. So the frequency of a sound wave, the result obtained as shown in the graph. Oh, so now we're going to have a frequency of that and that. So which are these frequencies? Of a source, of a listener? Of a listener, because they say a detector. That device, it could be device, or let's say someone is standing is going to be hearing that train siren. We can put that down, detector of face or a person. So now, if we look careful, this detector is going to hear two different type of frequencies. So what that mean? That tells you these. Excuse me, sorry. So that tells you. Apology. Sorry. So that tells you, meaning the bigger one, the bigger frequency means when this train was coming toward you, and this smaller frequency when the train was moving away. So look at this. So this is just a graph general. So here we don't have a frequency of a source. It's a listener because they say detector. So now this, why the frequency is bigger? Because the train when it was coming to you, but then it gets smaller because the train now was moving away from a detector or away from you. Does that make sense what I'm saying? So now we say, excuse me, you can even see here. So it was, they say constant frequency means you're going to be hearing the same frequency here. So here to here, this when the train was moving toward you, that's why you hear more frequency because that pitch is bigger because it's coming toward me. But now from here, because it's that from here you see solid line, mean the train was moving away. Now let's go to the question. They say state the Doppler effect in words. What is Doppler effect? Doppler effect means this is a change of a pitch. Like you see here, bigger pitch, and you hear smaller pitch. See? So that we call Doppler effects is the changing frequency of a sound detected by listener. Listener is like I said, detector, person or detector, whatever. Because the source, that train, I'm just saying that train and the listener, which is you, or we can call detector, have a different velocity, have different relative velocity. What does that mean? I'm standing, means my velocity is 0, but the train is coming, means it's going to have another velocity. So the relative velocity, see, we have what? Different relative velocity. See, that's why I'm going to hear different pitch. But if the train is standing and I'm standing, means I'm going to hear the same pitch. So the Doppler effects, like I said, this is a change in velocity or a pitch of a sound. See, so you can just check that one on the internet sometime. But yeah, I can just put it up for you here. Doppler effect, just in case if you didn't catch that one. So this is Doppler effects. You see what I'm saying? That's the definition of Doppler effect. I put it for you here, right here. So this is change in frequency or pitch of the sound detected by listener, because the source and the listener have a different velocity relative to the medium of propagation. See, means medium propagation is like excuse me, so air, space, or whatever. So they have a difference. Okay. Now, let's go to the question now. Let's go to the question. Excuse me, sorry. Let's go to the question number 2. So Doppler effect you done. I'm trying to put it down. Okay. Excuse me, sorry. Now let's go to the We just clean up and then let's go to the question. The question is way easy. It's actually easier than even definition. I always say this. So, oh, could you say that? Oh yes, it is. Okay. So just before we go further, right? Look, some people might be new here. You see what I'm saying? So please, man, just come right here, subscribe to a platform here. You see what I'm saying? Right here, subscribe here if you're new. If you have not yet, make sure you come here, subscribe to Mutrana Bantu Academy. Also, just go to my platform where you can see what we do for the community. You know, we have a various program where we give back to the community. Also, I have my merchandise, office. Go show us support. You see, and you can see what we do. Also, if you can donate, I'm not saying, you know, only if it's convenience to somebody feel like okay, there's a need. You're more than welcome to do that. You know, have a website and mobile application where you can do it. Okay. So just go and see what we do in a channel called Mutrana Kosi. So Mutrana Kosi is more of the giving back to the community, giving back to the vulnerable people, people homeless, feeding program. I have a feeding program and give it back because we have to do something for our community. You know, we can just wait for people to do for us. Okay. Okay. They say kindness, charity start from home. Charity start from home. Let's go. So now here they say. A Doppler Effects, we're done with that. So now let's say a detector, a recorded frequency of 300. Oh, so look, a detector is going to record this. But just quickly, if you look at this, what tell you? The record was bigger here because the train was coming toward me. That's why the frequency was bigger. But here it was 200 because it's moving away from me. So when the train was moving toward or away, the train was moving toward the detector. But when the record this one, when the train was moving what away from so this is away from the detector, but this is toward the detector or a listener, you can say. Now let's go to 6.3. So 6.3, we're going to use a very small formula. Let me show you. So this is a formula here we're going to use. This formula is very, very important. See what I'm saying? Those are formula you're going to use all the time, okay? And this V represents velocity of the medium of propagation, but for the most case or for now is airspace. So airspace is where you hear that pitch, whatever. When the detector is there, is gonna. So the V is the velocity of medium propagation. Is always constant, which 340 meter per second. The medium of propagation, velocity of medium propagation is constant. Now let's come to the VL. VL is the velocity of a listener. The velocity of a listener is gonna be 0 for this case. You know why? Because you standing, the detector is just there. The detector was not moving. So the velocity of a listener is gonna be 0 VL. And VS is the velocity of a source. But for now, we don't know. They just say this train is gonna be moving with a constant speed. But we don't know the speed of a train. So for that case, we don't know the speed of a train. Now, let's go to the Fs. Fs is the frequency of a source. Do we know the frequency of a source? No, we don't know. We only know the frequency of a listener, and we have two cases. The frequency of a listener when the train was moving toward us, and the frequency of a listener when the train was moving away from us. Means we're going to have to solve two cases. So Fs, frequency of a source, we don't know. But from the question here, they say, if you look careful, they say is gonna the siren train is gonna move with the constant along the horizontal track or meet a sound of a constant frequency. Also, Fs is just a constant, but we don't know. Okay, so now we're gonna say now, let's put in a formula inside of solve. So we're gonna say now frequency of a listener from that formula. Okay, so now let's solve this question here. So question 1, 6.3. So Doppler Effects, in Doppler Effects, this is the formula we're going to use all the time. So now let me explain to you when and how you can use it. Look, now we have a plus and minus and plus and minus. When you're going to use plus, when you're going to use minus. Look, the trick is very simple. Let me show you. If you stationary, you're standing, let's say you're here, you're standing. And if the source is coming to you, this is a trick you should remember. This is a tricky. Look. Most of the time, I always tell people help them. You need to know a little tricky sometimes. Like to study is a strategy. So let me show you the strategy. If you stationary or you standing as a source, as a listener because you're listening. something's coming toward you. So what you do, you see the denominator, what you do, you minus, use the minus, that's all. So just look at the denominator and then remember, is something coming to me? Oh yes, it's coming to me. Or if it's coming to me, and then come to the formula, use minus at the denominator. And then if you know this minus, and the other one on top, you switch minus, so it's going to be FL V V. Okay, it's coming to me, right? Okay, what I'm going to do if it's coming to me, oh, minus. And here, if this minus, the other one must be plus, other way around always. It's always other way around. That's all. Now, what about if it's coming? What about if it's coming to you? Excuse me. If it's moving away from you, or if the source is moving away from me, if the source is moving away from me, what you do? Look at the denominator, and then what you do? You plus and you minus. Simple as that. Done. So now, if you go back to the question now, let's go back to the question. They say 6.1. 6.1. For 6.1, sorry, my thing is kind of okay. So for 6.1, they say Doppler effects. So Doppler effects, we say, so this is a change in velocity or a pitch. Pitch, we say the frequency, like the way how you're gonna hear, oh, boom, 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 boom. You see? Oh, or when the train is coming. So that change in the pitch, that pitch is like how you hear that frequency. Okay. So changing the pitch of a sound detected by listener. If I make sound, you're the one who's gonna listen. It means I'm a source and you're gonna hear it. So the way how you detect, see, because me is a source and you is a listener. See, there's a what? Different relative velocity of the medium of the propagation. Medium propagation means the like here you see is the air, space. That's a medium of the propagation. So you can simply memorize this. I can just put it up for you here. So maybe in the future you can use this. Okay, you know why I do this now again? Because I realized at first when I put it up here it was not visible because yeah, so I think now you can see it very, very clear. So these are definitions here of the Doppler effect. So this is a Doppler effect definition. Is a change in the frequency or pitch of a sound detected by the listener because the source, or like a source, let's say train is coming or ambulance, and the listener means the one who hear that pitch of a sound of a train or a car horn or the ambulance have a different relative velocity to the medium of the propagation, means like air, space. Okay, so the first one is done. Now let's go to the second one, 6.2. Okay, for 6.2, here they say 6.2. Excuse me, sorry. So for 6.2 here they say does the detector record the frequency of this one when the train moving toward or away? When it's moving toward, because this frequency is higher. So when the train was moving toward me, I hear more frequency. And we measure frequency in hertz, but these are here smaller because when the train was moving away, that's why here what? Low frequency. Now let's go to 6.3. So these are frequency of a listener, both of them. The first one is second, but this is bigger because when the train siren was coming toward the detector for this case like a listener, and this is smaller because the train was moving away from the detector. Now let's go to 6.3. So 6.3, I say we're going to use this formula here. Now let's see how we go solve. See how we can solve. It's easy. So now you're gonna have to use different two cases. That case and that case. FL. Now we go. What is FL? FL is the frequency of a listener. For this case we have 3148 equal to V. V is the velocity on the medium of the propagation. But most of the cases they're gonna give to you in a formula sheet. But at 340, but sometimes they change, they say 333, but for now just use 340. So we're going to say 340, or for the most case just use 340. So okay, now but before we do that we have to look at the denominator. So are we going to plus or minus? this frequency of that one is bigger because the train was coming to the detector. So we say if it's coming means you're gonna minus, and this v means 340 because this is a constant. V is a constant, is the velocity or the speed of sound in the air space, which is always 340. So we're gonna say here 340 minus, because it's coming, the source siren is going toward the detector for this frequency. And then Vs, we don't know. Velocity of a source, we don't know. Do we know source? No. They only say it's going to move with a constant frequency. We don't know the velocity of a source. Okay, so if this minus, this is going to be plus, obvious. If it's minus, that's what it's going to be. Okay. And then Fs, frequency of a source, do we have? We don't have frequency of a source. Okay, let's call this one Fs. We don't know. Let's call this one the first question. Now we can do the same game now for the second one. So for the second one, I'll say frequency of a listener we have when the train was moving away, which is going to be 2073 equal to 340, which is constant. Okay, now let's look at the denominator. So for us to have this means the train was moving away. That's over here, less frequency. So what we're going to do if it's moving away, we plus here if it's moving away. So here we're going to say our v equal to 340, always constant. Velocity of a source, we don't know. The velocity of a train, which is the source, we don't know. So here we're going to have to say this plus, this must be minus. And then the velocity of a listener is 0. Why? Because the detector is just there. It's not moving. That's what we say. Velocity equal to 0. And the frequency of a source. So what we're going to do, look. We have the first equation. And then we have the same second equation. So what we can do, rather just make it Fs the subjects. So make the Fs the subjects, okay? Excuse me, sorry. So make a subjects. What I'll do, I'll cross multiplication. I'll say this is over 1. So I can say cross multiplication and then make it Fs the subject. 2073 times that, and then 1 times that. So this 340 minus 0 just is 340. Fs. So if I cross multiplication, say 2073. Let me start with this one first. Let's cross multiplication here. So 31 for 18. Bracket times 340 because we cross like that. Minus Vs, and then cross with this one, it's going to be equal 1 times there, 340 times this, 340 times Fs is going to be 340 Fs. So what we want to do, divided by 340 throughout. This and this cancel. So Fs equal to that, because this is going to be 1 1, so Fs equal to that one. So I can simply say Fs here. But in the solution exam, show everything, because that's how you get a lot of marks. So we do the same thing here and make Fs the subject. So it's going to look almost similar with that. So it's going to be 2073 multiplied by that. 2073 multiplied by 340 plus Vs over okay, and then over 340 equal to Fs. You can just make subjects slowly. This and this, you get that. This and this is going to be it's going to be 340 divided by 340 divided by 340. So we're going to have this, okay? So this is what we have. So we have this and you have this. So both of them equal to Fs. So let's equate them together. I hope you understand how I got this one, right? Because of just cross multiplication. This times that, this and this, because this is going to be 340 Fs, 340, but I divided by 340 divided by 340. So this and this cancels always to get that one. So if we equate now, let's just equate and finish up the question. I don't like to say the question for a long time sometimes. So if you equate means I'm going to equate this equal to this, because this equal to Fs and this equal to Fs. So this equal to that one. So I say 340 minus Fs over 340 equal to this, which is 20, 34, 340 plus Fs over 340. See? But I'm sure you show everything, right? So you're going to erase this. So what we're going to do now here, we can simply cancel these two because they're the same. This and this cancel. So we have this equal to that one. So I can simply expand it because I'm left with that one. Like, let's go step by step. 480 multiplied by 340 minus Vs equal to 2073 multiplied by 340 plus Vs. So you can expand this. To simplify, we know how to simplify quadratic, and then you're going to get your Vs because multiply, expand, and then you're going to get your Vs. You know how to expand it, but if you want, I can show you. Okay, let's multiply. It's going to be 31 times 340. 31480 multiplied by 340. Okay, so 31480 multiplied by 340. And this is going to give us 10, 7, 70, 320 minus, because we multiply this on this, going to give us 3148 Vs equal to, multiply that one, which is 2073. Okay, you're going to get 70 for 80, 70 for 820. Okay, now multiply for the second one is going to give us plus 2073 Vs. So then you can make Vs the subjects, means this is minus and this is plus. Put them in one side, work it out, and then take this one back here because this is a number, this is a number. You 12th grade, you should know how to solve that. Then you're going to get Vs equal to 70 meter per second. So that's what the velocity of a source means, the velocity of a train when it was coming. The train which was producing the siren. Oh, so we have velocity of a source now. Now let's go back here to the question, see if that's what they want. I got the speed of a train. Oh yeah, of course, yeah, this is speed of a train. So now let me add some extra thing here because sometimes they do ask this. Let's say they say find the frequency of a source and find wavelength of a source. Let's say they say that. I'm gonna get that. They want what? Frequency of a source and wavelength of a source. But remember, we had here 31480 and the what? 340 plus 0 over 3 times, oh my apologies, sorry. From the formula, we say we got velocity of a listener equal to V plus minus the listener, and then we say V, and they say plus or minus velocity of a source, and then multiply by frequency of a source. Yeah, we can get this Fs. Look, I can get frequency of a source. Let me tell you how. Look, frequency of a listener, there's two cases. I can use either two cases. Okay, let me use the one when the train was coming to me. Means I'm going to say here 3148 equal to 340. Oh, so since it's coming to me here, we know it's going to be plus. So it's going to be 340 since it's coming to me. Okay, Vs we have now, which equal to 70, because we just calculate now for this one. So equal to 70 meter per second square. So then I'm going to say here, here's going to be minus, because remember it's coming to me, that's why it's high frequency. So here's plus and the 70, and then this is going to be minus 0, and then here we can find Fs. Yes, of course. So put that in a calculator. I'll show you how to put in a calculator. That one is easy. Come here, let's plug in a calculator here. Let's put a calculator. So we say here, so I'm gonna take okay, let's do this. 3148, and then I'm gonna divide the whole group, means all of this here. Let me show you clear, because look, I can just take this, divide by all of this, and then I'll get Fs. Oh, let me get the value of this phase, and then I'll divide here, and I'll divide here. Oh, you can just take this, divide by all this group, and then I'll get Fs. See what I'm saying? So then I can say divide by all that group. Oh, my apology. Divide by all that group. So we divide by bracket and then what? 340. 340 minus 0, which is going to be just a 0. And they say under what? 340, and then we plus 70, coming close, and this is going to give us 3796.12. Ooh, so the frequency is very big. The frequency of a source, frequency of source, equal to that one right there. Okay, so we can simply say frequency of a source. Now we know 31 96 96 11 31 37 96 7 37 96 7. So frequency of a source is not part of the question, like I said. We just wait. So frequency is equal to 37 96.12. Let me see, is that correct? I don't want to get 37 96 12. Yes, in approximation. Hertz. This is the frequency of a source. Hertz. The unit of frequency is Hz. Hertz, which is hertz. Okay, now if I got frequency of a source, now they say find the wavelength of a source. So there's a formula here I want to show you, very crucial. This formula here is very important. You need to know, you have to. Oh, sorry. This formula here, very important. Say velocity of anything equal to frequency times wavelengths. So for that case, now I can come back here and finalize. Hey, look, this is not part of the question, right? But because sometimes they don't want to answer the same question, they always change. So that's why I want you to understand how these things works. So we're going to say velocity equal to wavelength times frequency. But for this case, we say we have velocity of a source, we have a frequency of a source. So they want to get wavelengths of a source. I can get it because now look, velocity of a source I do have. So I can say for this case, velocity of a source, wavelengths of a source, and frequency of a source. Velocity of a source I have 70 equal to, we're looking for the wavelengths of frequency of a source. So we have this one here, 37 96, and then 12 what? Hertz. So I want to get wavelengths, means divide by 37 96.12 divided by 37 96.12. This and this cancel. So our wavelengths of a source equal, so I can simply divide 70 divided by 70. Okay, let's go. So let's come here and say, okay, let's just get it. So we say now, okay, I can just put in a calculator, simple. Okay, so put that on the calculator, that's going to give us a wave. Okay, let me just divide here. So say 70 divide, I use this calculator, same as that. 70 divide by 37 96.12. Okay, so this is going to be 0.0184. So this is going to give us a wavelengths of a source 0.0184. But wavelength is the length, so measure using what? Meter. Yeah, that's how. So we have already wavelengths of a source, we have a frequency of a source, and we have a velocity of a source. Sometimes they do ask you to do it. Now, but this was not part of the question. It's for me to get you understand. Let's go to the last part. So the last part here, they say now the detector is start to record the frequency of a moving siren when the train. Oh, so the detector, that listener or that device, it start to record when it was 300 meters away. Oh, so we got now distance of a source. Changing distance, so you can say distance of a source equal to 350 meters. Now, what did they say here? They say, but we have also velocity of a source. What do they want? They say calculate the time taken. It's easy, man. We do this in 4th grade. Velocity equal to distance over time. Velocity equal changing distance over changing time. This meaning change. This sign here meaning change. So velocity equal changing distance over changing time. Do you have a velocity? Oh yes, we do have 70. We had it already. The velocity of a source. Detectors have to regulate the frequency of a moving train when. Oh, so moving train means that's a source, and we have already velocity of a source, distance of a train from a detector, and we can use our formula which say velocity equal to changing distance over changing time. Velocity we have, so I can just plug and say 70 equal distance we have 350 over time we're looking for. So I can simply cross multiplication. So 70 times t is going to be 70 t equal to 1 times 353, 50 divided by 70 divided by 70. This in this cancel, so time taken is going to be equal to 5 what? Second. So the time which is going to indicate is going to be 5 seconds, and that's going to be the end of the question for this case. Like I say, you might be new to this program, so please come to the Mutwana Kosi. This is my other YouTube channel where we do the real thing of the community, man. You know, be part of it. You can sign, you know, you can benefit from that program also, you know, and it's just so inspiration that we can start to do by our own, you see, by uplifting vulnerable people and people who need our skills, either our time or knowledge. Go ahead whenever it's possible. You know, you can go, you can be a donor, be part of our donor of a program that we started, so we can continue to give back to the people, you know, even though all this program is just self projects, I can say is independent projects, see, just to give back. And because I always have a heart since when I was very young to give back to the community, you know? And that's how I was raised too, because I was given a lot when I was little young. And apart from that, you know, come subscribe here, man. You know, just come subscribe here. You can see here, man, I got a lot of love for the brothers and sisters on the continent of Africa. And this is me when I was baby. I don't know if you can see me there. And this is part of the projects that I want to do when I go to the virus community. See, lay to sound for our community. If you don't know, I'm Mutwana Nkosi. That's my name. You can call me Mutwana Nkosi. That's my name. And I hope to see you very soon. Thanks a lot of peace. And I'm out.